kind of get a head start on 6.3 parametric equations in motion. In the interest of time, I'm asking that you'll read this page, what you'll learn about and why. It's very important. I'm not trying to minimize its importance. But I want to just kind of set a brief little overview as to what this whole parametric equation thing is about. And so parametric equations, which you're going to see in a second, have three variables, t, x, and y. T is used as our variable because t often represents time. And so after a certain amount of time, let's say time is equal to 1 second, then we want to know what the x placement and the y position, I should use the word position, is of a particular object. And here is a little bit more. I'm looking in this green box down here, and I'm going to ask you to read through that a little more thoroughly. We're going to look at some applications in class. Right now, I just want to go through the algebra of it. One thing you'll notice about parametric equations is that you will see two different equations, one for x, one for y, both of which are in terms of t. T, again, is our parameter, and we are going to complete this XYT chart using the indicated range of values for t and using, of course, the given equations. So I'm just going to pick some random values, -6, -4, -2, 0, 2, and 4. I chose a not so random list of numbers, even numbers, and what we're going to do is find the corresponding x and y values. This is pretty straightforward. So if t is -6, then I'm going to plug in -6 for t into this equation for x, and you get you get positive 24 when you do that. And then you're going to plug in that same -6 t value into your y equation to get the corresponding y value. And so what I'm going to ask you to do is continue on completing that chart, and then check back with me after you have completed it. So I completed the chart, and you can see and compare our XY values, and hopefully we're on the same track with that. I want you to see what this looks like in your calculator. And so when you go to calculator, go onto your calculator in push mode, you'll come up with a screen like this if you're using 84. For those of you with Inspires, which I'm so proud you have, you're going to have to kind of navigate this and figure out how to get to these settings. I'm in my menu settings, and here I'm going to change my mode from function to parametric. And that's really all I need to change for this problem, but in a minute I'm going to need to be in radian mode. So go ahead and change this to radian mode now, since that's where we're going to need to be. And then when you go to window, go ahead and adjust your window settings according to the problem. Your -6 to 4 values for t is what you see that I've input here for t-min, t-max. T-step, you want it to be really small because that's telling your computer, your calculator rather, how often you want it to plot points. And so the smaller that t-step, the smaller it steps through these t values, the smoother your curve. So I set mine at 0.05. And then you're going to change your other values to, x max is, oh gosh, I need to change these. So x min is -5, x max is +5, our y min and max are -3 and 6. And then we're going to graph this, and so when you go to y equals, you'll notice how you have two separate entry lines, one for that x equation. We're going to type in t squared plus 2t. Where's that t? Well, you're going to use the same variable, t squared. You're going to use the same key that you used for variables before, at xt theta n, only now that you're in parametric mode, when you push it, the variable t is what's going to appear instead of x. I lost my place. T squared plus 2t. Okay, 2t. Then the second one, I'm kind of slow, is t plus 1. And now let's graph it. How lovely is that? It's not a function, and in function mode we would not have been able to graph that as one single equation. So here you get to see that we can now work with curves, we can work with non-functions. So we can do some cool things with parametrics. We'll see it in a minute. Let's continue on to this activity here. So an n point star can be modeled parametrically as follows. So if n is even, and we know even numbers are 2, 4, 6, 8, then you can plug these two values in, or these two equations in, to your parametric screen. And if n is odd, and we know odd numbers are 1, 3, 5, and so forth, then you're going to use this equation. And so what we're going to do, what I'm going to ask you to do, is to go ahead and set your calculator mode according to what you see here. Notice how we have a big T step. That's important, and you'll see why in a second for this particular problem. So what I'm going to do is I'm going to put into my equation first, let's see, let's let n equal, let's try n equals 4. And then I'm going to type in these equations for when n equals 5. So you do that, I'll do that, and we'll compare in just a moment. So I loaded up a few into my calculator. The first one, I let n equals 4 like we said we would do. And so I only have that first one highlighted, so you'll only see what happens when n is 4. Notice how there's 4 vertices, 4 sides, but 4 vertices is what's most important. And then when it equals 5, go through this kind of quickly. Notice I'm now going to highlight the second parametric equation. And when n equals 5, notice how I have a 5-point star, which is kind of cool. And the last one, I didn't ask you to do this, but I just have to show you this n equals 6 thing. So cool. So generalizations we can make. So let's push enter there. So this is what you see when you have a 6-point star. And look at that. Notice when n equals 6, it produces a 12-point star. And so there's some generalizations you can make when n is even, when is odd, how many vertices, how many points your star will have. Cool stuff. Just a little tease for what parametric equations can do. We kept our t-step large because we didn't want it to be curvy. We wanted those straight line segments. Here's another equation, another example of some parametrics. So if you were to graph this parametric equation and changing your interval for t, so first graphing it with t values from -3 to 1 will produce this graph. But if you expand your t values a little bit, you would get this. And if you expand it just a tad bit more, you can see you get a more complete picture. So, you know, it's important, as you can see, to, have a good range for your t values. Let's look at how to eliminate the parameter. Very important. So it says eliminate the parameter and identify the graph. So remember we said t is the parameter, so we want to rewrite this equation, this parametric equation, which is currently in terms of x, y, and t. We want to rewrite it so that there's no longer t. So what we do is, since x equals t plus 1, let's figure out what t is. So t, just a little quick algebra, subtract 1 from both sides, is equal to x minus 1. We're going to take this value of t and just do a quick little substitution into this y equation. So we get y equals 2 times x minus 1, which you know already this is a line, 2x minus 2. It's a line whose slope is 2 and whose y-intercept is negative 2. And so it says eliminate the parameter. In other words, rewrite it in terms of just x and y, eliminate the parameter t, and identify the graph of this parametric. Now I couldn't tell, maybe we couldn't tell looking at our parametric equation what we were going to get, but once you remove the parameter, you know that all we have is a line whose slope is 2 and whose y-intercept is negative 2. Oftentimes they're going to ask you to describe it, so if it's a line, you can describe it in terms of its slope and y-intercept. We have trig functions, and it's not going to be as simple to just solve for t in this case. So here's a strategy. So because x equals 3 cosine t, and follow me for a second, it won't make perfect sense until it kind of comes together. If x equals 3 cosine t. Then x squared equals 9 cosine squared t. Now I know that makes sense to you. You might be wondering, why are you doing that? Just hold on. Likewise, if y is 3 sine t, I know you can follow this quick little pattern, then y squared equals 9 sine squared t. We're going to try to utilize a trigonometric identity, that sine squared plus cosine squared identity, and you'll have to create that sometimes in problems like this. So x squared plus y squared, so if I want to add x squared, I want to add this to that, well then that's going to equal this plus that, so 9 cosine squared t plus 9 sine squared t. And so you can probably see what's coming up, that we have in here our sine squared t plus cosine squared t, and here nothing has happened. We still have that x squared plus y squared. So in the end, once we utilize our infamous trigonometric identity, we end up with x squared plus y squared equals 9. We eliminated the parameter. We took this parametric equation written in terms of x, y, and t. We rewrote it in terms of just x and y. Now, upon inspection, when you see your initial parametric, it's unclear what that is. Now we could tell that this is a circle. And I always want you to describe what it is that you have. So it's a circle, but more specifically, it's a circle whose center is 0, 0. You should remember this. And whose radius, you should know this, it's 3. I hope you weren't going to say that it's 9. So I always give a brief little description, just kind of keeping our skills sharp and making sure we're concise in our description. Common little thing that we'll do from time to time. So what does that say about, you see all that, so what does that say about x equals 5 and 5 cosine t and y equals sine t? Well, I hope you kind of saw the pattern, but if we were to do the same thing, we would have 25 sine squared plus cosine squared t. I'm cutting some steps, but I hope you can see why I'm able to do that. If not, look back at your previous example. So I cut some steps, but you could see that in this case we get x squared plus y squared equals 25, another circle whose radius is 5. So in general, if you have x equals n cosine t and y equals n sine t, that's always going to yield a circle. A circle in the form of x squared plus y squared equals n squared. Okay. Cool little pattern that is going to be necessary for you to know. I only have a few seconds left. I wanted to talk about resultant, but it seems like this is what we're going to have to pick up with next time. So I'm hoping that you have an idea of what a parametric equation is, that it's expressed in terms of x, y, and t. It allows us to describe motion with respect to time, and it allows us to describe, I said motion, but I mean it allows us to describe its horizontal and vertical position with respect to time. Also, I want you to be able to eliminate the parameter on various equations. That is it. We'll pick up in class next time.